That is retake given during class time, higher of two scores given. I did update it in Schoology. Maybe it might take a few minutes for Infinite Campus, but as soon as you see that comment, you know that that's the higher of the two scores. So now when you do your final grade calculator, now you have like an accurate grade for your semester grade right now. Um, what else about that? There was something else I don't remember. If you turned in stuff like the past couple days, maybe like some IXL skills, that's the only way to like significantly increase your grade, then I haven't graded it yet. But most things were graded like Monday. So anyway, Unit 5, the first one was the one asked about. What was Unit 5 about? Even from reading these questions, what type of function is described in these questions? There's three major functions in ninth grade. Two of them we really focused on this semester. What was Unit 5 about? What did we start the semester with talking about a lot? Exponential functions. And the reason why that's important to remember is because it can make some of these problems a lot easier, especially problem 1 of this set. Because we have a car was originally sold for $18,000, loses 1/5 of its value each year after it was bought. After 4 years, how much is the car worth? That one would be a lot easier if you knew the setup for exponential functions. And then it's just a matter of identifying those couple things that you need, plugging in a number and getting the answer. There is a way to problem solve it without knowing the setup. But then in number 2, it says write an equation for the value of the car C T years after its release. So you end up needing the equation anyway. So let's try and start there. What's the general setup for an exponential function? So just like how you can tell me linear is y equals mx plus b, you have to tell me exponential functions are y equals what? Look in your notes, look in the notes on Schoology, Unit 5, or one of the first things we did. Would make the problem a whole lot easier. It's like if we were doing a linear function and you know how we usually identify like slope and y-intercept, slope being your rate of change, y-intercept being some sort of starting amount, and you just like identify those two things in the problem. It's really similar for exponential functions, but the formula for exponential functions is different. So what's the formula for exponential functions? Okay. Y equals a times b to the x. So exponential, like use the name to kind of tell you. It's where x is the exponent, exponential. Earlier someone said a times b squared, right? No, that's not what we want. We want x to be the exponent. The squared is for your quadratic functions, which was like unit 6 and 7. Unit 5 is exponential. So x is the exponent. That is the general setup. We've also seen it expressed where b is 1 plus or minus r. Depending on what information they give you in the problem, you might want to use one or the other, but they are the same. Like they're both for exponential functions. The x is the exponent, and it's repeated multiplication time. Even if it's decreasing, it's still multiplication. multiplication, you'll see why. It's like, but what does A stand for in our exponential functions? The original amount, so I like saying initial amount. What was the par originally? So when we're setting this up and it wants the value of the car to be C, you could do C of P, but you just put C equals 18,000 for the initial amount. And then B stands for what? Okay, so yes, but be a little bit more specific. So it's like how it's changing. Yes, that is true. How do exponential functions change? Do they add the same amount each time? What do they do each time? What's B stand for? Remember, I am checking these. So when I come around and see that there's blank papers, even after the 30 minutes I gave you today just to work on it, and then you're not even writing down, like I know not to check papers. That if you're like 0.01 away from the next grade, that you'll deserve the grade you get. So my question was, what is these gonna work in exponential function? Common back to thinking. Did say I did not give up and tell you, but she did say. B stands for what? And what do we do with factors? So exponential functions multiply each time. Even if the numbers are getting smaller over time, that just means that you're multiplying by a number that is what? If it's getting smaller. Maybe relate it to this, where it's expressed this way. Okay, do me a favor, if your desk is not oriented where all you have to do is like turn your head to look, then fix it to where it is. Because I'm tired of like me asking you and you're just staring like this. So like, stand up, lift your desk, I shouldn't be looking at the back of your heads. When I say, oh, look at what B is, and you're still not even looking at me, like. So my question was, if your numbers are getting smaller as you're multiplying, what does that mean? I can multiply by 1.5, that's a decimal, and the number will be getting smaller. It's less than 1. Okay, so I'm multiplying by a decimal, just means 0 and 1. Right? So this is decreasing over time. That's why this one might be better for you to understand, because it has the 1 plus or minus. If it's decreasing over time, is it 1 plus or 1 minus? Minus. And R stands for rate, typically as a decimal, but it's mostly like what it's losing, like the growth rate. Because I guess it could be growing if it's a plus. But whatever the growth rate is, if it's a percentage, convert it to the decimal. But they're not giving us a percentage. They're saying it's losing 1/5. So I'll be doing 1 minus 1/5. And it wants it to the x power. And x is usually time. And they want us to use t for years after it's released. So to follow the instructions the way that they want it, I'm gonna put a t, not an x. If you don't use the variables they want, you will get at least a little bit. But that you could put as an answer. What is 1 minus 1/5? 4/5. Also equivalent to 0.8. Right, but it needs to be something that I just need to plug in the number here, and it'll give me the value of the car. So then when we go back to part 1 and it says, how much is the car worth? All you have to do is plug in for your t value. What do I need to plug in if I want to know for after 4 years? Then I plug in a 4. And then use the calculator for the rest. The only thing that I tend to see people mess up on for that is what's in the parentheses. I guarantee, even though we're talking about it right now, people are gonna put 1/5. Even though that's not what it's keeping, but it's losing. You multiply by what it's keeping, which is 4/5 or about like 80%, so you could put 0.8 in there as well. And after 4 years, it's worth about $7,372.80. So make sure you round to look like money. In first hour, nobody could tell me even a little bit of the formula. So we had to do number 1 by like figuring out what 1/5 of it was, subtracting it from the original, figuring out what 1/5 of that was, subtracting it from that amount. Like the 1/5 of 18,000, I think is like 3,600. Let me check. Like 3,600. You can't just subtract 3,600 4 times. Because then it's not exponential, then it's linear. You have to, if you were doing that, because I mean, if you forget this, at least try to figure out the answer. You have to do 1,800 minus 3,600 to see what that amount is, times that amount by 1/5, and then subtract it from that, and like, and do that. That's like one something you get from not. The equation is much easier. All right, other questions? Table 3, set up. I'll make you stand. All right, no other questions? First one on unit 6. Okay, so the expression 16t squared represents the distance in feet an object falls after t seconds. The object is dropped from a height of 502 feet. What is the height in feet of the object 5 seconds after it's dropped? And write an expression representing the height of the object in feet seconds after it is dropped. So what you have a few ways of going about this. I think number 2, if I were to have that expression, then I could easily answer number 1. So we have done problems relating to projectile motion before, and you have to remember, like if we're saying h for height and t for seconds, that it's generally this setup. So negative 16t squared plus vt plus s. This is not for this question. This is just your setup. This is something you can memorize for tomorrow, because you're not using any notes. But this comes from gravity. This is always the case. unless it's not on Earth, then this is always the case. It's always going to be in front of the x squared. V stands for velocity. So if it tells you, oh, it's being launched at a velocity of 80 meters per second or something like that, that will go in front of the linear term. And S is for starting height. So I would expect velocity to be 0 if something is just being dropped versus being thrown. Right? Those speeds would be a lot different. So when I reread the information again, it includes the 16t squared, but you have to remember that's just how much it's traveling. If we want to know like its current height at any given time, we need that to be negative. So that way it has like this U shape, the downward facing U shape. So just know that. And then it just says it's being dropped from a height of 502 feet. It doesn't say anything about velocity. So when I'm writing my expression, I would have it be negative 16t squared, no velocity, so like 0t, which would just cancel out that term anyway, plus 502 was the starting height. And it said expression, so technically you wouldn't have an equal sign. You'd just have that. And then me having that, if I want to know the height of the object 5 seconds after it's dropped, I plug in a 5 and use the calculator for the rest. No. Okay, so 102 is the answer for part 1, and here's the reasoning. And don't forget your units, 102 feet. One more thing, you could check your answer with Desmos. I'm sure some of you will actually not even have number 2, maybe like you completely forget. You could find your answer by probably adjusting the window would be best, but you'd have to click and drag onto this U shape where it touches 5 exactly. And then you could see that Y value when you do that. I know I'm like zoomed all the way down. Let me try pulling it up. So you could check your answer that way. I mean, doing this alone won't necessarily help you make the expression. It also doesn't give you like the expression to just type in, but at least you could check that answer too. All right, questions on any others? Number 1 on unit 7. All right, so I've been telling you ever since this first showed up in the notes that you'll have a problem just like this, and here it is. It's telling you what the solutions are. So just telling me what the solutions are, typing it into Desmos and telling me the x-intercepts won't get you any points because it literally tells you already. The solutions are 1, 6, and 5, 6. Show how to find these solutions by completing the square. So it has to be that method to get the full points. If you do a different method, I mean, something would be better than nothing, but like you will not get nearly the full points if you did like quadratic formula, factoring, graphing. It definitely doesn't even show any work. So completing the square would get you the full points, even if you could just do a few steps correctly. And the first step for completing the square is to do what? what form does it want it to be in? It does not. Because it's already in standard form set equal to 0. Completing the square is the only one that doesn't want that. Very good. So this one wants the x terms alone on one side. So you need to move this other term. How do I move the 5 over 36? And whatever you do on one side of the equal sign. So then I get x squared minus x equals negative 5 over 36. That alone will get you some points. There's like 4 steps in completing the square. That would be like 2.5 points. Because each problem will be out of 10 points. So anyway, that's step 1. What's step 2? Okay, so take half of b, then what? And then what do you do after that? All right. So we're gonna take half of b, square it, then add it to both sides. What's my b value on this? And what is half of -1? And what is negative 0.5 squared? And you could have done the fraction. This time the decimal is not bad because it's a decimal that ends, like it doesn't go on forever. If it is a decimal that goes on forever, you need to put the fraction, otherwise you'll get the wrong answer at the end. But honestly, this one's not bad. I'm going to use a calculator anyway, so you could add a decimal to a fraction, no problem doing that. So when I add the 0.25 to both sides, this is what I have so far. And I need to do this fraction plus 0.25, so let me do that. I wouldn't even try to do it by hand. That would be a waste of time, in my opinion. So in the calculator, doing -5 over 36 plus 0.25 gives me that decimal. It goes on forever. I don't want to have to round it, so I'm going to press this button for the fraction. And so it's equal to 1/9 on the right side. And that's me doing the second step. So yes, these steps are like very oddly specific. We've already gone over why these steps are the way that they are. Really, you just have to memorize and follow them. That's it. So like that's the first 2 steps done correctly. What's the next step? All right, back to the completing the square creates a perfect square over here. I mean, if you didn't remember that, you could try factoring it. Me what multiplies to 0.25 and adds to -1. And knowing that it has to be the same number here and here that do that, what plus itself will add to -1? What plus itself will add to -1? I can't even get like up. There you go. Nothing. Not just 0.5, but how do I make it add to a -1? Okay, so they both have to be negative. Do we see that? We've done that before. We did that in the lesson. Whenever we know it's a perfect square trinomial and it has to be the same number here and here, I'm really just taking half of b. That was like the whole purpose of taking half of b, squaring it, adding it to both sides, so that we could make something on this side that looks like this. x minus 0.5 squared, and it's minus because that's what half of b was, it was negative. So we can write it in the condensed form, and now it's just an isolating x situation. Before I couldn't, because there was x squared and x, there was no way to combine them. But by me creating a perfect square trinomial and doing all that, I can now write it easier, and I just have to undo what's being done. So what's opposite of squaring? Whatever you do on one side. I get x minus 0.5 plus or minus, and you can square root in your calculator, but don't forget the plus or minus when you do that. Plus or minus 1/3 is what it is. What's opposite of subtracting 0.5? So then I'm doing that. Don't put your paper away because I need to check it. And then don't forget to do the positive 1/3 plus 0.5. Again, use your calculator. I'll even show you. It's really easy. But it already told you what the answers are. Guys, freeze. I need to check your papers. And I don't like hearing all this noise over my recording either. So 1/3 plus 0.5 is 5/6. The other answer I get from doing is negative 1/3 because that's where the plus or minus was. Negative 1/3 plus 0.5 is 1/6, which it told you the answers to begin with anyway. I will record my other classes. You can watch the recording